A very good morning to one and all present over here. Thank you for giving me an opportunity to teach online. Today, I have chosen math as a subject and I'm going to take trigonometry as a concept. So the word trigonometry is derived from a Greek word, and if you split it into two different words, that is trigon and metry, both are the words derived from Greek. The first half of the word, meaning trigon, means triangle. The word tri means three and gon stands for angle. So it is a figure denoting three sides and three angles, which means it's a triangle. The second half of the word means metry, which means measurement. It's a word derived from Greek. The basic word is called metron, which means measurement. So the word trigonometry stands basically for the measurement of sides and angles of a triangle. Take, for example, a right angle triangle, say triangle ABC as shown in the figure on the left hand side. You can see that it is a right angle triangle where B is 90 degrees. The side just opposite to 90 degrees, which is the largest side of the triangle, is called as hypotenuse. And we have the two other sides, AB and BC. If we take angle C as theta, then we can say that the angle theta, opposite to that, we have a side which is AB. The side opposite to theta we call as opposite side, and the side just besides C is called as the adjacent side. So these are very important to know the basic ratios of trigonometry. So we shall see the basic terminologies which are used to represent the trigonometry. Now we have sine theta. Sine theta is given by the formula opposite side divided by hypotenuse. As we can see our figure, it can be written by AB divided by AC. Next we have cos theta. Cos theta is given by the formula adjacent side divided by hypotenuse. And that is given as per the figure. It is given by the formula BC by AC. Next we do have tan theta, which is given by the formula opposite by adjacent. As per our figure, it comes as AB divided by BC. So these are the basic trigonometric ratios. Beyond this, we have a few more terminologies. For example, cosecant theta. The cosecant theta is just the inverse of sine theta. So it is 1 divided by sine theta. Therefore, it becomes 1 by opposite by hypotenuse. Therefore, it becomes hypotenuse divided by opposite. We have next secant theta, which is the inverse of cos theta. So cos theta, we know that it is equal to adjacent by hypotenuse. So the inverse of cos theta would become hypotenuse divided by adjacent. The last, under this, we do have tan theta. So tan theta, opposite is cot theta. The inverse of tan theta is cot theta. So it is given by 1 divided by tan theta, which will be equal to adjacent divided by opposite. Under trigonometry, we have another important thing. It is called another important theorem, which is known as the Pythagoras Theorem. You would have definitely heard this word very often, and it is called Pythagoras Theorem, according to which, if we have a right angled triangle, the square of the hypotenuse will be equal to the sum of the squares of the other two sides. So in our figure, if we see AC square, it will be equal to AB square plus BC square, according to the figure, according to figure 1. So this finds great application in proving so many important theorems and also arriving at various identities in trigonometry. Given a particular value, in case we take figure 2 as our example, and if they have given like Sin C value is given as 3/5. And they ask us to find out the values of the other trigonometric ratio. Is it possible for us to find out? And the answer is yes. How? Let's see. If they give you sin C is equal to 3/5, we have already seen sin theta is given by the formula opposite by hypotenuse. So according to figure 2, we can say sin C is equal to AB divided by BC, which is equal to 3/5. From this, we can arrive at AB is equal to 3 and BC is equal to 5. Therefore, by using Pythagoras theorem, we can easily find out the value of AC, which is adjacent side, and that can be derived by Pythagoras theorem. That is, square root of the other two sides will be equal to hypotenuse. So, according to Pythagoras theorem, we shall be having BC square is equal to AB square plus AC square. When we use this, when we substitute the values of AB square and BC square, we will be getting the value of AC square as square root of 5 square, that is 25 minus 9, which will be, and you will be getting AC as 4. So once we get the value of the other side, the third side of the triangle, it will be easy for us to find out the unknown values. Now we have got all the three values. Let's substitute and find out. So using this, I can now find out cos. So cos C will be equal to adjacent by hypotenuse. Tan C will be equal to opposite, that is AB, by adjacent. Similarly, I can even find out secant, cosecant, and cot using formulas as we have derived earlier. So this is the basics. These whatever we saw until now are the basics of trigonometry, and it finds great use in proving many concepts and identities that we are going to see later. Hope you understood the session well. Thank you. Thank you for the opportunity.